In this part, we're going to take a look at showing our various weapon sprites. So in the previous episode, we got to the point where we can swing our attack and cycle through the various attack animations for our sword. And so now we want to get to the point where we can actually see our sword and see the two different types of swords that we have. So welcome to Barden, my name is Heinrich, and let's get into it. So to get our weapon sprite to show up, we're going to create our first weapon component today, and that is simply going to be our weapon sprite component. So let's come to our IDE and let's create our files. So in our weapons folder that we created earlier, I'm going to go ahead and create a new directory or folder, and I'm going to call this one components. In this folder, we can then go ahead and create two new scripts, and they're both going to be mono behaviors, so Unity scripts if you're using Writer. So the first one is going to be called WeaponComponent. This is going to be the base weapon component class that all of our weapon components inherit from. And it is just going to take care of some of the basic setup that all of our components need, like referencing our weapon. Before we do anything in here, let's also go ahead and create another script. And this one is going to be our WeaponSprite script. And so now what we want to do is our weapon sprite, instead of inheriting from mono behavior, is going to inherit from our weapon component class. And before we do anything else in our weapon sprite class, let's quickly come back to our weapon component class and just do some basic setup in here. So the first thing I want to do is I want to mark this class as abstract. So what that means is we can never attach this component directly to a weapon. We can't just attach a weapon component. We can only attach any of the classes that inherit from weapon component, because the weapon component class by itself isn't going to do much. After that, the first thing I want to do in here is let's go ahead and set up the reference to our weapon. So let's create a protected weapon, and we'll just call it weapon. And then let's go ahead and create the awake function. Now, our weapon components are also going to utilize the awake function. So instead of private void awake, let's go ahead and say protected virtual void, so that our weapon components can override the awake function. And then in here, we can just start by saying weapon equals get component, and the component type that we're looking for is just weapon. Okay, so back in our weapon sprite weapon component, let's start by talking about how this component works. So essentially what's going to happen is this component is going to look at our base sprite renderer, so the sprite renderer that is displaying our player without the weapon in its hand. We're going to reference that sprite renderer and listen for changes in its sprite. So whenever the sprite changes, we know, okay, we have to now update our current weapon sprite. So to do this, we need three things. We need a reference to our base sprite renderer, we need a reference to our weapon sprite renderer, and we need our weapon sprites that we want to display. So let's start with the sprite renderers. Let's declare a private sprite renderer. This is going to be our base sprite renderer. Then we have a private sprite renderer weapon sprite renderer. And just note that we have not yet created our weapon sprite game object. We'll do that in just a second. And then finally, we need our sprites that we're actually going to show. So we could do something like creating a serialized field, private sprite array like this called sprites, that is just going to hold all the weapon sprites. But we have one issue. We have three different attacks for the sword. So we have three sets of sprites that each correspond to each of the attacks. So instead of creating an array holding sprites, let's go ahead and declare another class real quick. And we'll just do this in the same file. So underneath our weapon sprite class, we'll say public class weapon sprites. All this class is going to have is a public sprite array that we will call sprites, like that. And I'm actually going to make this a public getter and a private setter. And then instead of declaring a sprite array in our weapon sprite class, we're going to declare a weapon sprites array, and let's just call it weapon sprites. So now that means we can set this array to size 3. So one of these objects for each one of our attacks, and then each one of those objects is going to have its own array of sprites. Now, we're going to be setting these sprites in the Unity inspector So we need to expose it to Unity so that we can serialize it. So the first thing we need to do is tag this class as serializable. So like that. Now, as you can see, this relies on the using system namespace. So after saying serializable there, we can come in front of our variable. And here we can do serialize field, but unfortunately this doesn't work with auto properties. So in addition to this, we need to say field at the front with a colon like that. So now we should be able to see this in the inspector. Before we go back to Unity, let's quickly go ahead and also set the reference to our two sprite renderers. So we'll do that in our awake function. So we'll start off by overriding our awake function. And then after base.awake, we can set these two references. Now our WeaponSprite component should already have a reference to the weapon class because of the WeaponComponent parent. And if we take a look at our weapon class, we have a reference to this base game object, which is where our base sprite renderer is going to sit. So instead of looking for this base game object again, we'll just make use of this. So instead of private, let's just go ahead and rename this to base game object with a capital B, like that. And then instead of private, let's make it public. And then finally, we'll change this into an auto property. So now we should be able to get this reference from our WeaponSprite class. Now, in addition to our base game object, let's also go ahead and reference our WeaponSprite game object that we're going to create in just a second. And we'll also just make it an auto property so that any other weapon component that might need to reference it can do so. So let's declare another private game object, and we'll call it WeaponSprite game object. Give it a getter and a private setter. Then we just need to come down to our awake function. And after we get our base game object, let's also just go ahead and get our WeaponSprite game object, which is equal to our transform.find. And in here we can just say WeaponSprite. So we just need to make sure we name the game object the same thing when we create it. And we want the game object. Okay, so with this reference set and these two variables being public, let's come back to our WeaponSprite class. And now in here in the awake function, let's start by saying our base sprite renderer equals weapon dot base game object dot get component, and the component type that we're looking for is our sprite renderer. Then we need to do our weapon sprite renderer equals weapon dot weapon sprite game object dot get component, and we're also looking for the sprite renderer. Now there might be one little issue, and before I say what it is, have a think about the code that we just wrote and see if you can spot any potential issues. I didn't spot it until I got error, so don't worry if you can't. But we have a sequencing issue, and that is that in order to set this reference to the sprite renderer, we are relying that our weapon class has already set its own reference to this base game object. So if our weapon sprite awake is called before our weapon awake, this is going to throw an error because our weapon class doesn't know about the base game object yet. It hasn't set that reference. So instead what we could do is we could move this to start, but unfortunately that yields another issue, which we'll talk about in just a second. Now, in later episodes in the project, the weapon script is always going to initialize first because our components, like the WeaponSprite component, won't be sitting on the weapon yet, and instead will be added later on. So this code will work perfectly fine as is, but unfortunately we're not there yet. So instead what I'm going to do is we're going to comment this out, and then we're going to leave ourselves a little note. I'm going to say to do fix this when we create weapon data. So just as a little reminder that this is the code that we want to use to avoid just an extra find search later on. It's not too important. But so instead of this, we need to go ahead and set our references correctly. And to do it, all we need to do is just find those game objects here instead of our weapon class. So we can say our base sprite renderer equals transform.find, and we're looking for the base game object. And then we can say .getComponent sprite renderer. Our weapon sprite renderer equals transform.find. We're looking for the weapon sprite game object. .getComponent sprite renderer. So now essentially this is doing the same thing, It's just now we're going to have 4 find calls, which are quite expensive, instead of just the 2. But for now, this is going to have to do. Okay, so let's talk about why we couldn't just move this into our start function, which would have guaranteed that it got called after all of our awakes. And that has to do with how we're listening for that sprite change event. Let's take a look at the Unity documentation for a second. Let's go to our scripting API, and let's just search up Sprite Renderer. You can see over here under the results, there is a Sprite Renderer.register sprite change callback. Let's take a look at what that is. So this is a function that we can call, and we can pass a Unity action to it. So a Unity action is just another delegate. It's essentially the same thing as an action. But what this means is we can pass a function to this, and it is going to call that function whenever the sprite changes. So it registers a callback to receive a notification when the sprite renderer sprite reference changes. So this is what we're going to make use of to determine when to actually change that sprite. So where do we call this? Well, just like subscribing to any of the other events that we've been working with so far, let's subscribe in the OnEnable function and unsubscribe in the OnDisable function. So after our awake function, let's go ahead and bring up our OnEnable function. And then in here, we can say base sprite renderer dot register sprite change callback. And to this, we now need to pass a function, which we haven't created yet. So let's actually go ahead and do that quickly. I'm going to do it above our awake function. It is going to be a private void. We'll call it handle base sprite change. And now this function needs to have an input parameter of sprite renderer, and I'm just going to call it SR. So this is where we're going to put the logic, but before we do that, let's come back to our OnEnable function. And to here, we just need to pass in our handle base sprite change. So notice again that we don't put the brackets at the end of this because we're passing it in as a reference and we're not actually calling the function. Now we just need to remember to unsubscribe in the OnDisable function. So OnDisable base sprite renderer dot unregister sprite change callback. And in here, again, we just pass in our handle base sprite change function. Okay, so let's go ahead and take a look at our handle base sprite change function. So what we want to do is every time we get notified that our base sprite has changed, we want to take a sprite from the WeaponSprites and put it in this WeaponSprite renderer. So something that we're going to need is a counter to keep track of which sprite we want to display. So we know we're always going to start with the first one. So this can just be a basic counter that counts from 0 up. So let's go ahead and declare a private int, and we'll call it current WeaponSprite index. And then in our handle base sprite change function, we can say WeaponSprite renderer dot sprite equals our WeaponSprites. And the element that we want from this array is going to be our current attack, so 0, 1, or 2 for the sword. So we can say weapon dot current attack counter. And so then this is going to give us a sprite array. So we can say then dot sprites, which is referring to this. And then the element we want here is our current WeaponSprite index. Okay, so I hope that makes sense. We start off by choosing our WeaponSprite object based on our current attack counter. And then from that object, we access the sprites variable. And then from there, we choose the sprite for the current WeaponSprite index. After that, we just need to increase our current WeaponSprite index. So current WeaponSprite index plus plus. Now we also just need to make sure that we reset our current WeaponSprite index whenever we start a new attack. So we want to do that whenever the weapon enters. Let's quickly take a look at our weapons script. So in here we have this public event action on exit, which gets invoked every time the exit function is called. Let's go ahead and create another one for the enter function. So public event action, and the action is called onEnter. Then we need to come down to our enter function. And let's just do it at the end of the enter function. We can say onEnter null coalescing operator invoke. Okay, so now whenever we enter an attack, we will invoke this event. And then we can come back to our WeaponSprite component. And in here, let's quickly create a function to handle enter. We'll say private void handle enter. And for now, this function simply does one thing. it just sets our current WeaponSprite index back to 0. Now we just need to make sure we subscribe this function to that event. So in our OnEnable, let's go ahead and say weapon.onEnter plus equals handle enter. Copy that, paste it in our OnDisable function, and change the plus equals to minus equals. Okay, so that's almost everything. Let's go back to Unity and let's quickly finish setting up our weapon on that end. In here, let's go ahead and open up our player game object and then come to our primary weapon. Let's right click on that and create another empty game object that we'll just call WeaponSprite. And again, make sure that is spelled exactly the same as what we passed to the find function. Then let's come to add component and add a sprite renderer. And before we do anything else, we need to remember to set our sorting layer to player. And let's set the ordering layer to 3. Now we can right click on our WeaponSprite, come down to where it says added game object and just say apply to prefab. So now our secondary weapon should also have it. Perfect. We can then come back to our primary weapon, click add component, and we want the WeaponSprite component that we just created. So you can see over here we have this WeaponSprites dropdown, which gives us an empty list currently. Before we add any of these sprites, let's also just go ahead and apply this to the prefab. And let's go ahead and quickly add these sprites. Let's add the first sword to our primary weapon and the second sword to our secondary weapon. So we can come to our sprites folder, player, combat, sword. Here we have sword 1. So let's expand that. And then let's come back to our primary weapon inspector. Let's lock this so that we can select things here without this changing. And before we drag in any sprites, let's create 3 elements in this WeaponSprites array. So again, each one of these corresponds to a different attack. So element 0 is going to hold the sprites 0 through 4 because each attack consists of 5 sprites. Drag that, oh, we can't drag that in, we have to open this. So we have to drag this into the sprites field over there. So there's our 5 sprites for the first attack. We then want sprites 5 through 9 for the second attack, and sprites 10 through 14 for the third attack. And now don't apply this to your prefab, otherwise it'll change it on the secondary weapon. But let's come to our secondary weapon, unlock the inspector, lock it again, and let's create 3 elements for the 3 attacks. Then let's expand our sword 2 sprites, and let's just do the same thing again. So sprites 0 through 4 for element 0, sprites 5 through 9 for element 1, and then sprites 10 through 14 for element 2. Okay, I think we're ready to test it out. Let's see what happens. I already know some things are about to go wonky, but that's okay. So as you can see, we have one issue. Our sword is kind of just flying here, but let's see what happens if we attack. Okay, so if we do our primary attack, you can see it looks pretty good. Our sword is following our player, except we then end up running into an index out of range exception, and I'll explain why in just a second. And if we do our secondary attack, it also works. But you can see we're having some issues. Okay, so what's happening? Well, when the game starts, our base sprite gets this empty sprite from the empty animation. So over here. So that triggers as a sprite change event, and our logic then goes, okay, it's an attack, we need to go get the first sprite and give that to our sprite renderer, which is why when we start the game, our swords are floating up here. That's the first frame of the first attack. So we need to make sure that we don't set the sprite if we're not attacking. And we also need to handle this index out of range exception, which is happening because when the attack finishes, the sprite still changes to the empty sprite. And so our WeaponSprite component still just thinks it's the next frame of the attack and tries to get another frame that doesn't exist. So we just need to quickly handle that. So to do that, let's come back to our code, and then let's come to our base weapon component class. So we're just going to create a boolean here for isAttackActive that is going to be set to true when we enter the attack and set to false when we exit. That way all of our components can make use of this information. Are we currently attacking or not? So after our weapon variable, let's go ahead and create another protected boolean and just call it isAttackActive. And so now we want to set this to true when we call the enter function and false when we call the exit function. So we need to subscribe to those events. So we're actually going to move that handle enter function from our WeaponSprite component up to our just weapon component. So let's create a protected virtual void, call it handle enter. And in here we'll say is attack active equals true. And then we can create a handle exit. So protected virtual void handle exit. And in here we say is attack active equals false. Now we just need to subscribe to the onEnter and onExit events. So for that we need our OnEnable and OnDisable functions. So let's say protected virtual void OnEnable. And in here we want to say weapon.onEnter plus equals our handle enter function, and weapon.onExit plus equals handle exit. Next, we want a protected virtual void OnDisable. And then in here, we can actually just copy this, paste it in here, and change this to minus equals and minus equals. But now we just need to come back to our WeaponSprite component. And then in here, you can see now that this handle enter is hiding our virtual function that we just created. So instead of private void, this needs to be protected override. And we can just get rid of this and move our current sprite index equals 0 up in here. We also need to come down to our OnEnable and OnDisable functions. I wonder if I can just fix it like this. Okay, so that's set it to override, but don't forget to call base.onEnable inside of this function. So the OnDisable as well, make that an override, protected override, and in here, base.onDisable, like that. So now we have this Boolean that is telling us if the attack is active or not. And so what we'll do is we'll come back to our handle-base-sprite change function. And so in here, all we'll say is if not is attack active, so the sprite is changing, but we're not currently in an attack, we'll just say WeaponSprite renderer.sprite equals null. So that's just going to set our WeaponSprite to nothing, which is perfect. We then also just want to make sure we return after this, so that this doesn't still get called when we don't want it to. So now we shouldn't be getting any more errors with this current WeaponSprite index being out of range, as long as our number of sprites match up. But maybe we just need to put in a little bit of code to debug an error if we detect that that is happening. So what I'm actually going to do is, on top of this, let's go ahead and say var current attack sprites equals, and then let's move this WeaponSprites weapon.currentCounter.sprites. Take that, put that over here. So this is now the sprite array that is over here. Okay. Then we can say if current WeaponSprite index is greater than or equal to our current attack sprite dot length. And I actually want to call this sprites and not sprite. Sprites like that. Okay. So if our current WeaponSprite index is greater than the amount of sprites that we have to work with, let's just throw a warning. So debug.log warning. And in here, let's just say which weapon we're currently working with. So squiggly brackets, weapon.name, and weapon sprites length mismatch. Something like that. Don't forget your $sign at the front so that it can print this variable in here. And this is length like that. So here, if we're going to get an error, at least we'll know which weapon we need to go look at. And then if we do get this error, let's just return again so that we make sure we don't accidentally try and set it to something that we don't want. Now we just need to come over here and say current attack sprites, and we want the current WeaponSprite index element. So that should take care of all of it. Let's go ahead and try it out. So let's run the game. And as you can see, we no longer have our weapons floating like that. And if we left click, there we go. There is our primary attack. And if we right click, there is our secondary attack. So we have two different swords swinging. How awesome is that? I'm super stoked with how far we've come already. Okay, so that's going to do it for today. This is probably a bit on the longer side again. Sorry about that. So now because we have made our first weapon component, in the next part, we're going to start looking at weapon data before we make any other components. Otherwise, we're just going to have a whole lot of refactoring to do later down the line. So the next part, we're going to have to do a little bit of refactoring just to get the weapon data set up. But that is quite a complicated topic, so we'll take our time and just move nice and slow through that, make sure we understand everything. But yeah, that does it for now. So remember, if you want early access to the source code that I'm using as a reference for this project, it is available to all of my Patreon tiers over on Patreon, and it will be available to everybody eventually once this series is finished. And so with that mentioned, before I go, I would just like to say thank you to all of my supporters and wonderful people over on Patreon, and a huge special thank you to Cody Lee, SM, Madger Sins, Jake Scarupa, Patrick, Itami, Mike Rodriguez, Nathan Ackley, and Christopher Rios for your support on Patreon. You guys are absolute mad lads, and I hope you all have a wonderful day.